Alright guys, so there's the last um method or the last type of root, which is the quadratic repeated. Alright. Remember is the one where the power, basically quadratic to a power. Alright, it's just a power. It's similar to the linear in terms of the steps. It's just all you have to remember is that the numerator instead of being a or b or c is ax plus b. So like in this one here, we have on top 2x squared plus 4x plus 2 to the power of 2. So it's similar. So you'll start with 1, then it'll be plus, and it'll be cx plus d over, yeah, 2x squared plus 4x plus 2 all to the power of 2. Right? It's the same pattern. Right? It's literally the same pattern. It's just the numerator, so it'll be ax plus b form. Right? So obviously if you have more, they go up in terms of the letters. Right? So this one here, a little different. This now we're starting to combine the two of them, right? So we have two different types of roots going on. This here is a normal quadratic root, and this one is a repeated quadratic root. Yeah, because it's the power two. Only this is to the power two. So this by itself and this is to the power two. So actually what going on here is two type of roots. So that's the same steps. You know how to write this. So this would be ax plus b on 2x squared plus 4. Then we had to handle this one here. So to handle this one here, there's a repeated quadratic. So it's the same pattern. So it'll be cx plus d. And it will start off with 1. Okay, that's combining the two. And then you go again. So a, b, c, d, e, x plus f. And you go up any power. So it'll be 2x squared plus 4x to the power of 2. Yeah, remember you have to stop at that. And that's it. So there's like what has happened when you combine and you have different types of roots. You literally look at them individually and come write it in its perfect fraction form. Yeah, and that is well, that's recap. So since the last video, you all make sure you all know these. Yeah, make sure you know the steps. Yeah, make sure you know the steps. And I'll be posting the link to the solutions that I do in the description so you could download it so you'll have it. Alright, so let me try this one. So it's the same steps. Yeah, so that's good. So step one, look at the numerator, denominator. This cannot be factorized anymore. Nice. Step two, the type. We have quadratic, repeated. Quadratic because it has power of x is 2, and repeated because obviously the entire thing to the power of 2, right? So we can write it in a partial fraction form. So this would be ax plus b all on x squared plus 2, and it'll be plus cx plus d all on, and that's increase the power by 1, and it stop because you reach 2. Yeah, nice. Step 2 now, we have to solve for a, b, c, and d. Remember I told you that's multiply both sides by this here. So on the left hand side, it will cancel. And multiplying this, remember you could write this when you multiply it's basically x squared plus 2 by x squared plus 2. So this by that, you end up with ax plus b by x squared plus 2. And then this by that will cancel. So you could just end up with cx plus d. Yeah? And now we're trying to solve for a, b, c, and d. So then it's a similar method, the expand and equating coefficient, right? So it'd be x plus 5, expanding this out. All right, so you end up with a by that. So it'd be ax cubed. Ax by 2 will be plus 2ax. B by that will be plus bx squared. B by that will be plus 2b. And then plus cx plus d. Yeah, so let's write in some dummy variables. So 0x cubed plus 0x squared plus x plus 5 is equal to ax cubed. Grouping the x squares, so we have bx squared. Grouping the x's together, we have 2a plus c, and the rest are constants. Yeah, so now let this cancel to be. Right, everything accounted for. So now we could equate coefficients. So let's write a line. So we say equating coefficients of x. We will have 0 x cubed is equal to ax cubed. We will have 0 x squared is equal to x squared. We have x is equal to x 2a plus c. And then we have 5 is equal to 2b plus d. So we can name this 1, 2, 3, and 4. Yeah, so now we could solve some of them. So for a, the x's will cancel, so a will end up equal to 0. For the b's will also cancel. So x squared cancel x squared, so b will end up being 0. Yeah, so now we could actually plug it in. So for this one here, canceling everything, we'll have 1 is equal to 2a plus c when I cancel the x. And since a is 0, plugging it in will be 0. So c plus 0 plus 2 by 0, 0 is equal to 1. So c will equal to 1. And then to solve for d, since b is 0, we'll have b 2 by b, 2 by 0 is 0 equal to 5. So d, so d is 5. So therefore a is 0, b is 0, c is 1, and d is 5. Yeah, so now we just write it back in its partial fraction form. So where we at? I think I'll just write it here. All right, study button. So we have a, well, since a and b are 0, basically don't have anything for this piece here. So cx plus d, so cx, so that'll be 1x plus 5, all on x squared plus 2 squared. Um, that was x plus 5 on x plus 2 squared. Yeah, and that is it in partial fraction form. Yeah, so that'll be the end of the series. So we started with the linear, we did the linear repeated, the quadratic, and the quadratic repeated, right? So I'll post these solutions so y'all can have it. All the best. Be safe.